The most shocking discovery about the 9/11 attacks wasn't, the sheer scale of the tragedy itself. It was the fact that the U.S. government literally already had the data to stop it.
Right. It's just wild when you actually look back at the timeline.
Yeah, the flight school records of the hijackers were documented. The suspicious international wire transfers were logged. The names of the operatives were sitting right there on a federal watch list.
The pieces were all there.
Exactly. Their travel patterns had been heavily flagged weeks before the first plane even hit the tower.
It is a staggering historical paradox. I mean, you look at that and you have to ask how the most well-funded, powerful intelligence apparatus on Earth, having all the necessary puzzle pieces, completely failed to put the picture together.
Right. And the official 9/11 Commission report actually gave a specific term for that failure. They didn't call it a lack of raw intelligence. They called it a failure of imagination.
Which is an interesting way to put it.
But, what does that actually mean from a technical standpoint?
Well, it basically means the infrastructure itself lacked the capacity to cross-reference reality.
Right.
The CIA's databases were completely siloed from the FBI's databases.
Right.
And the NSA was operating on entirely different, legacy mainframes.
So they couldn't talk to each other.
Exactly. You had brilliant, dedicated intelligence analysts, but each one was trapped looking at an isolated fragment of data. The agency simply didn't possess the software architecture required to merge those fragments, visualize the overlaps, and see the overarching threat.
So our mission for this deep dive is to unpack how that exact problem, the government's inability to connect the dots, was ultimately solved by a completely unrelated group of civilian coders in Silicon Valley.
Yeah, it's a fascinating pivot.
We are tracing the wild trajectory of Palantir. It's a highly secretive intelligence company, currently valued at around $350 billion.
Massive.
Yeah. And we're going to explore how an algorithmic defense built to stop Russian syndicates from draining money online evolved into the digital brain of the CIA.
And how it drove the hunt for Osama bin Laden.
Right. And ultimately, we'll get into how its new, unapologetic manifesto has sparked a fierce global debate about surveillance.
To really understand the underlying architecture of Palantir, you have to look at the crucible it was forged in, which is the 1999 dot-com boom.
Right, the early internet days.
Yeah, a startup called PayPal was experiencing unprecedented hypergrowth. I mean, hitting 5 million users in 12 months by allowing people to instantly email money across the globe.
But behind the scenes of that explosive growth, they were quietly bleeding to death. They were losing $10 million every single month to organized fraud.
Right. It was a highly coordinated, automated money laundering pipeline operated primarily out of Russia.
Wow.
The mechanics were brutal. Hackers would compromise an American bank, steal tens of thousands of credit card numbers, and use automated bots to create synthetic identities on PayPal.
Walk me through that mechanism. What does a synthetic identity pipeline actually look like in practice?
So the bots would link a stolen credit card to a fake account, transfer a seemingly innocuous amount, say $500, to a second fake account.
Like putting 4 groceries in the memo line or something.
Exactly, making it look normal. And then they'd instantly withdraw that $500 to an offshore bank. By the time the actual credit card holder in Ohio noticed the charge and initiated a chargeback through Visa, the money was completely gone.
And Visa would reverse the charge and hit PayPal with the bill.
Yeah. Multiply those microtransactions by thousands of automated bots a day, and the company was just bleeding out.
So PayPal tries to build an automated defense, right? They study the fraud, identify the attack patterns, and write rigid algorithms to block it.
They tried, yeah.
Yeah.
But writing static rules against a dynamic, intelligent adversary is just a losing battle.
It's like a game of whack-a-mole. PayPal blocks Russian IP addresses.
And the syndicates immediately route their traffic through American proxy servers to mask their location.
Right. Or PayPal writes a rule to flag $500 transfers, so the hackers instantly pivot to sending $249.
Exactly. The engineers were trying to solve a human behavioral problem with rigid mathematical equations.
They needed a system that could adapt as fast as the hackers did. A chess match, not a math test.
That was the epiphany of PayPal's co-founder, Max Levchin. He realized that algorithms are phenomenal at processing volume, but they have zero intuition.
Right. Machines see rigid parameters. Humans see stories.
Humans see the anomalies. So Levchin built a new system named Igor.
Igor.
Good name. Yeah. And Igor didn't replace the human fraud analysts. It digested all the raw data IP addresses, transaction times, browser fingerprints, and visualized it on a single interface.
Let me pause on browser fingerprint for a second, because that's a crucial concept for you listening. Even if a hacker successfully changes their IP address or uses a proxy, their actual computer leaves a unique digital shadow.
Right, the hardware itself.
Yeah, it's the specific combination of their screen resolution, their operating system, the exact fonts they have installed. That unique configuration gives away their identity.
And before Igor, an analyst would have to manually query different databases to find those hidden overlaps, which took hours.
Just impossible at scale.
Right. But Igor automatically extracted those fingerprints and mapped them visually. Suddenly, an analyst could look at a graph and instantly see that 47 different PayPal accounts using 47 different names and IP addresses all shared the exact same browser fingerprint.
Oh, wow. So the machine surfaces the hidden connections, the human spots the narrative and freezes the network.
Exactly. That symbiosis dropped PayPal's fraud by 70%. It literally saved the company.
So now let's fast forward to the post-9/11 landscape. PayPal's co-founder Peter Thiel is watching the intelligence failures dominate the news, and he recognizes the structural flaw immediately.
Yeah, he sees the exact same scattered data crisis that PayPal had just survived.
The government had the wire transfers, the watch lists, the flight logs. They just lacked the architectural framework to visualize the overlaps.
So Thiel decides to package that PayPal methodology, build a platform for national security, and he pitches Silicon Valley venture capitalists in 2003.
And they laughed him out of the room.
Total rejection.
Yeah.
Because building enterprise software for the federal government was viewed as a bureaucratic nightmare.
It's slow, boring, and not profitable compared to consumer tech.
Exactly. So Thiel had to fund it himself with $30 million of his own capital. He brings in Alex Karp to run the new company, Palantir, but they immediately hit a wall.
Right.
They have no product, no security clearance, and zero credibility in Washington.
To bypass that roadblock, Thiel pursues a tiny $2 million investment from In-Q-Tel, which is the venture capital arm of the CIA.
Which is brilliant, honestly.
Right. He didn't even need the capital. He did it purely for the branding. The moment Palantir is backed by In-Q-Tel, they carry the halo of being a CIA-vetted asset.
It opened the doors to the intelligence community. They finally secured a meeting at the CIA in 2005 to demo their software.
Okay, but hold on. You can buy a CIA logo for your pitch deck, but Palantir was still just a group of tech developers from Palo Alto. How do civilian coders convince highly classified intelligence officers to trust their software?
Well, the short answer is they didn't initially. That first CIA demo was an absolute failure.
Wait, really?
Yeah. The Silicon Valley engineers had built this sleek interface designed for a problem they assumed the CIA had.
Oh, classic tech hubris.
Exactly. They didn't understand the daily reality of intelligence work. They didn't know that analysts spent hours manually reading unstructured cables, or how they had to log into 5 different air-gapped mainframes just to verify a single alias.
So Palantir realizes they can't engineer a solution from a vacuum in California. They actually have to understand the friction points firsthand.
Which led to a radical operational pivot. Palantir pioneered this concept of the forward-deployed engineer.
What does that mean exactly?
They packed up their top developers and embedded them directly inside the CIA headquarters in Langley.
Wow.
These engineers were sitting next to analysts, eating lunch with them, watching them cross-reference terrorist networks in real time.
That is a massive feedback loop. An analyst complains that they can't seamlessly pull a license plate record into a communications graph, and the engineer sitting beside them just writes the code to integrate that database overnight.
By the next morning, the feature is live. Palantir wasn't just shipping a finished product. They were co-creating a bespoke data ontology with the actual end users.
And this iterative process lasted for years, resulting in the platform they called Palantir Gotham.
But that methodology of embedding engineers didn't stop in the sterile environment of an intelligence agency.
Right. They took those civilian coders and deployed them directly into active war zones.
Yeah, by 2008, the ground reality in Iraq and Afghanistan was pretty grim. The primary threat to U.S. forces wasn't infantry combat. It was improvised explosive devices.
IEDs. Roadside bombs were driving casualty rates to catastrophic levels.
And the military was collecting mountains of raw data patrol logs, blast crater reports, intercepted radio frequencies, but they couldn't synthesize it fast enough to predict attacks.
So Palantir sends those forward-deployed engineers into the desert. They live in tents, talk to the soldiers, and configure Gotham for the battlefield. But how does Gotham actually synthesize that data? We keep saying it connects the dots, but what is the actual mechanism?
So Gotham relies on a concept called an ontology. Instead of organizing data in static spreadsheets, Gotham translates raw intelligence into objects and relationships.
Okay, give me an example.
A person is an object. A cell phone is an object. A mosque is an object. The system maps the relationships between them in a graph database.
Oh, so it turns the entire theater of war into a massive digital detective board, like the kind you see in movies with the red string connecting photos and thumbtacks.
Exactly like that, except it is processing billions of data points simultaneously.
That visualization changed everything. Soldiers would input data, and Gotham would surface the hidden matrix.
Yeah, it could reveal that IEDs on a specific supply route consistently detonated on Tuesdays between 2 p.m. and 4 p.m., always within a 400-meter radius of a specific marketplace.
And we're always preceded by a cluster of 12 specific phone numbers pinging a local cell tower.
Right. It moves the military from reactive to predictive. The 82nd Airborne utilized this to increase their bomb diffusion rate significantly, neutralizing nearly 700 bomb makers in an 18-month window.
Which is just incredible. And that capability to structure the unstructured set the stage for probably the most complex intelligence challenge in modern history, the 2011 hunt for Osama bin Laden.
For a decade, the trail was entirely cold. No digital footprint, no intercepted calls. The only thread the CIA had was the nickname of a trusted courier, Kuwaiti.
But finding one unidentified courier using a nickname across the globe is an impossible manual task. So the CIA ingests an overwhelming data set into Gotham. 3 million diplomatic telegrams, 170,000 satellite images, and 8,000 hours of intercepted audio.
It's just a mind-boggling amount of information.
Right, but how do you map unstructured data like 8,000 hours of audio into a graph database?
Well, Gotham utilizes natural language processing and metadata extraction. Even if the audio is a mess of static and encrypted chatter, the system extracts the metadata.
Like who called who?
Yeah. Who called who, at what time, for how long, from which geographic coordinates. It turns that audio file into an object, links it to a geographic object, and links that to a known terrorist network.
The sheer speed of that integration is staggering. Human analysts previously needed 72 hours to manually trace a single financial transaction through the network.
And Gotham processed the global matrix and completed those traces in 12 minutes.
12 minutes.
Right.
Oh. The system illuminated a connection between a known terrorist operative's phone number and a localized cellular ping in a specific region of Pakistan.
And that visualization allowed analysts to track the courier's metadata for months. Every movement, every geographic ping, leading directly to a walled compound in Abbottabad.
A compound with no internet and no phone lines, but one that was exhibiting highly anomalous behaviors.
Right, like burning a suspicious volume of trash for a supposedly empty residence.
Now, to be clear, Gotham didn't find bin Laden on its own. It provided the intelligence architecture that allowed human analysts to orchestrate the Navy SEAL raid.
Exactly. But after the Abbottabad operation, Palantir's valuation just skyrocketed.
The architecture that hunted synthetic fraud in Silicon Valley and terrorists in Pakistan is now deeply embedded across global defense departments, local law enforcement, and corporate supply chains.
Which brings us to today. And it introduces a massive ideological tension surrounding the company.
Right, because Palantir's CEO, Alex Karp, recently published what many consider a manifesto. It's been heavily discussed in his recent book and across social media.
His philosophy is totally unambiguous. He argues that if a U.S. Marine requires a superior rifle, the defense industry should build it.
And he believes the exact same moral imperative applies to software.
Right. Karp is articulating a deeply militant, pro-Western ideology. Palantir explicitly rejects the idea of being a neutral tech vendor. They position their technology as the essential digital armor required to defend Western hegemony in an increasingly unstable world.
And I want to be clear to you listening, in this deep dive, we aren't taking sides here. We're just examining this huge ideological tension.
Yeah, it's a very complicated issue.
But Karp is essentially arguing that Palantir is building a digital shield for the West. And yet critics look at the exact same software and see the ultimate architecture for a police state.
The friction really stems from the scale and application of that capability. Consider the analysis from Mark Kokelberg, a prominent technology philosopher.
What's his take on it?
He characterizes Palantir's overarching ideology as techno-fascism.
That's a heavy term.
It is. His core argument is that Palantir is not merely providing software. They are exporting a military-industrial paradigm. The concern is that by giving a government an omniscient, godlike view of its population's data, you provide authorities the perfect mechanism to systematically repress citizens under the guise of national security.
And you see this tension playing out in real-world deployments globally. Palantir has formed a strategic partnership with Israel's defense ministry to provide AI-driven battlefield analytics.
Right. AI-driven analytics basically means the system is instantly processing drone footage, intercept data, and ground reports to model out combat scenarios.
And there are heavy critiques alleging this software helps generate human target lists in Gaza.
Which Palantir firmly denies, though their deep integration into the conflict is a matter of public record.
Similarly, defense analysts report that Palantir's platform was utilized by the U.S. military to process the intelligence that enabled the targeting of Iranian General Qasem Soleimani.
The technology fundamentally accelerates the kill chain.
But domestically, the applications are just as polarizing. The U.S. Immigration and Customs Enforcement Agency, ICE, utilizes Palantir's systems to track undocumented immigrants.
And the software doesn't just look at a static list of names. It actively ingests biometrics, social media activity, toll booth records, and workplace entry logs.
So it creates a near real-time tracking matrix for domestic law enforcement.
Palantir has also heavily marketed the capability of predictive policing.
Which sounds like something out of Minority Report. How does a police department actually predict a crime?
By feeding historical arrest records, social network affiliations, and geographic crime data into the ontology, the algorithmic model calculates probability scores.
Oh, essentially forecasting which individuals are statistically most likely to commit an offense.
Right, or where a crime is most likely to occur, allowing police to deploy resources preemptively.
But the obvious counterargument there is that historical data is often inherently biased. If you train an algorithm on decades of over-policing in specific neighborhoods, the algorithm simply predicts that those same neighborhoods need more policing.
Right, it creates a self-fulfilling loop. And that is the crux of the global debate. The capability to map the future is undeniably powerful when you are stopping a terrorist network.
But when that same predictive machinery is turned inward on a domestic population, critics like Kokelberg warn that it fundamentally shifts the power dynamic.
Law enforcement agencies might be purchasing software, but they are also adopting a philosophical architecture where total security supersedes individual privacy.
We have covered immense ground in this deep dive. We traced how the need to combat automated microtransactions at PayPal birthed an entirely new way for humans to interact with data.
It proves that the most formidable technology doesn't replace human intuition. It acts as a multiplier.
Turning human analysts into superhumans capable of finding the invisible threads of reality.
But that superhuman capability requires an unprecedented level of restraint. The architecture is incredibly effective. The variables are how it is aimed, who controls the interface, and what data we allow to be fed into the machine.
We began this conversation by discussing a failure of imagination that left us vulnerable. But it leaves you with a very different kind of question to consider as you look at the future of mass data integration.
Yeah, a much more existential one.
If an algorithmic system becomes so incredibly precise at mapping out human behavior that it can reliably predict our actions before we even take them, at what point does the digital shield built to protect a free society fundamentally change what it means to be free?